fallen, I would have been happy. No, that's wrong. Good morning. Yeah, I heard I wasn't going to get usurped, and quite frankly, I'm okay with that. I'm Martin Levy. I'm from Hurricane Electric. I know a bunch of you know me, but what Josh just said is really why I wanted a spot today, was because there is this misconception on the amount of traffic that exists globally in IPv6 world. And I really came to the conclusion that at some point in time, someone has to go put some real numbers up on the screen and stand behind them and make sure that what we're talking about here is important enough to pay attention to. Now, Dave gave a talk yesterday, and it's going to be very different than mine. I'm going to give you a bit of a rah-rah talk. Now, those that know me know I'm going to give you a rah-rah talk. But at the end, I'm also going to turn around and try a little bit of self-criticism. So I'm going to go through a couple of things. The easy one. Just nail the coffin on this one. It's done. We've talked about it. There's plenty of IPv6 peering out there. We come from a peering and routing community. Let's just not talk about that ever again. The last slide, you'll ever hear from me at one of these conferences. Well, unless you're going to GPF in 3 days, and then you're going to hear it again. I'm going to talk about the traffic levels, and I'm going to pick some. I'm going to talk a little bit verbally about stuff I can, that's easy to talk about, some that's hard to talk about. And the final part I'm going to talk about is, does this really matter? So, again, the opening that Josh gave me is the cynical response. You can easily put together a panel of people who will talk about either sides of this argument. But I'm going to talk about the fact that, does the traffic levels really, is that really the issue that we have with V6, or are we going to go back and talk about some of the stuff that Dave talked about yesterday? So, all over the world, there's no place where it's hard to find a V6 exchange where you're going to find another exchange. These are all places that we either know, love, participate in, or have built. Some are distant, some are local. The NANOG guys are meeting in a couple of days' time in New Zealand. They've got 2 or 3 exchanges there, all of which are happily V6. Other places in the world without a problem. This graph, though, is sort of a measure of what's going on at those various locations. This is data that's been highly interpreted through about 3 different stages. So it's a bunch of Oregon data that is collected and then interpreted by Jeff Houston. I then took that data historically and went out and processed through it to go and work out how many interconnects, how many adjacencies are between different V6 backbones. Now, we all know that there's peering, and we all know that there is exchanges, but the question is, how much is it being used? So this is the sum of all of those adjacencies that can be found. Not the number of sessions, because an adjacency between 2 backbones may exist in multiple locations, but this is just the adjacency count. And it's rising steadily. It goes up or down, and we've looked at why that is. There's a few holes in the data here. That's just a data collection issue, but it doesn't change the overall trend. And I went and looked yesterday on our backbone, and we're just above 400 BGP neighbors in the V6 world on our side. And I know we're very aggressive about this, but the bottom line is that there's a lot of players. They are getting their peering act together. There is traffic. Sorry. And the net of this is, that's the proof numbers-wise that we needed to see that things are happening. So there's a couple of success, there's a couple of mistakes. There's a couple of success stories here. In reality, most of the IXs who have been successful in the V6 world, who have managed to talk to their neighbors, are sitting there and actually promoting. They're remembering to edit their homepage or equivalent page. They're remembering to put their IPv6 addresses on their members list, not just the V4 addresses. They are looking at either easy allocation methods that make it easy. But keep in mind, exchange points are inherently layer 2. So therefore, this shouldn't be hard. Getting reverse DNS seems to be a lot harder. Getting reverse DNS and convincing exchange points to do that, which, by the way, is useful because guess what? That enables you to look and see whether you have a particular neighbor on there. Ah, look, I know that reverse DNS. That could be somebody I want to peer with. But there's a few mistakes. Some exchanges are still doing 2 ports, one for v6, one for v4. That's sometimes useful if you're building up a network and you're testing it on a couple of side routers. But if you're dual stacking, then you really only need the single port. I'm going to reference you, but I didn't know where it was. There's a best practices document out there. Roger from Lacnic has been the primary author or the author of it, and well worth tracking down. I know it's gone through EuroX and a few other places, I believe. And the last one, which I just find pretty funny, is that we found a few people who have talked about the fact that exchanges are wanting to bill the customer for an additional address, a v6 address. And that's going to be a little bit of a limitation. And if anybody thinks and finds that and you know, wants to go correct that, please do. It seems to be a negative step for doing something that's obvious, like adding v6 to a layer 2 exchange. Okay, so let's talk about traffic. So I'm done with the peering. Doesn't need to be talked about anymore. So I grabbed a couple of graphs, and I have a caveat here. Doing flow stats is an issue of having faith in data. So we actually had to throw away most of our flow stats as of about 3 weeks ago when we found an interesting little problem and something that we had to, you know, basically realize we didn't have the confidence level on the data. The numbers were higher, which, you know, for us we thought was great, but it actually turns out that, you know, now we have a higher confidence factor, so I've got some useful numbers. What we did was we took all the data over our whole backbone and looked at making sure we weren't double counting and looking at where we were getting v6 traffic, and that was our numbers. We were running at about you know, just below about a gig's worth of bandwidth over the backbone, summed on so essentially all the inbound and outbound ports between source and destination. And then we jumped literally about 5 days ago, last week, and I spent some time sitting there going, okay, what interesting customer has just turned up with a whole bunch more v6 traffic? And is that the norm? Are we going to see big jumps as opposed to incremental growth? So I'll show you where that traffic is, and we'll talk a little bit about it in a moment. But I also wanted to go get one other graph that also dealt and addressed one issue that people have is, you know, is there any peering traffic? So I went out and I went through a bunch of different peers and randomly, without name, picked one particular peer and realized that, you know, we peer globally. We have both got a fair amount of customers. And I went out and looked at the traffic. And there, just summed easily, was about 60 or 70 megs of traffic between one peer and ourselves. Again, I'm not here to turn around and say there is terabits worth of bandwidth. I want to show that there's real bandwidth, and that therefore this is something that's worth taking a little bit more seriously. And the comment, you know, it's the comment about there only being 1 or 2 or 3 megabits worth of traffic, so why bother doing this, sort of really gets the nail, you know, in the coffin, and we're done with that conversation. So that was a summary of about 5 or 6 peering sessions over about a week. Seems about consistent with what we were expecting. I went off and looked at the specific traffic on particular exchanges. Now, some of the exchanges have got published information on their v6s flow data. Obviously not on a per port basis because that's customer dependent. So I looked at our traffic. And so on the Links exchange in London, where we have a fair amount of peers, you know, I was looking at around 20 to 30 megabits worth of average traffic. You know, there's a set of peers, a set of international peers there. Really wasn't a problem. You know, that seemed about right. AMSIX has a different story. It has a lot more traffic. And it has a lot more traffic for a couple of different reasons. it has a mixture of customers, two disparate customers actually that really move the most amount of traffic, or peers, should I say. One of which is the fact that we see a lot of Usenet traffic. And this is sort of becoming a well-known fact, but there's becoming more and more Usenet traffic that's been moved over to v6 from v4. And that's really the key phrase there. It's being moved over from v6, or v4 to v6. There is a simple movement of traffic over protocols. It's not a creation of a new killer app for v6. It's not a brand new website that's only available for v6. It's just simply the movement of traffic. And this may be one of the easiest norms to see on the v6 world, because it's between players that agree that they're both running v6. This is not even, in this case, to an end user.
I'm just wondering if you think that phenomenon is something like the BitTorrent phenomenon, where BitTorrent traffic gets moved over to v6 because nobody has filtering capability. Really? I mean, that's real.
No, it's actually, with you're specifically referencing 1.8 microtorrent release and the various v6 code inside that.
Yeah.
Yeah, and there was a jump exactly at that point, but actually we're seeing more Usenet traffic than what we think is BitTorrent traffic. But it makes sense, yes. There's one more part about that which I'll address in a moment. What's also interesting is that we saw another set of peering turn up about 4 days ago, and I just put the, or 4 or 5 days ago, and I just put the graph in there, where we suddenly saw for one particular customer a whole jump of this 100+ megabits worth of traffic. And we went off and looked at where it was, and it was one customer to one peer across the Atlantic, and it was database replication code, specifically between two data centers that were, or two entities that were the same entity. And so this is, again, an example of v4 to v6 migration of traffic that's being done by known entities, not being done by end users, which are either on a v6-enabled access or not. So again, the traffic levels, or the traffic in the v6 world, people are starting to recognize that internal to applications, internal to multi-site applications, that there's as much reason to use v6 as there is v4. I'll address that at the end. But this actually may hit some of what's going on with at least with microtorrent. There was a very good talk at APNIC, which had some stats on this, and it got me thinking. Back in August, went back and looked at some of the traffic. It took us a long time to get there. So we started looking at 6 to 4, and we started looking at not just the core networking. We had a pretty good IPv6 backbone. We knew we were peering. We knew we had a lot of customer traffic. We knew that part was dealt with. Now what happens in all the edge conditions? And 6 to 4 was the first one that we looked at. 6 to 4 as a protocol exists. In fact, I've got some stats on just how much it exists later on. But we realized that there was a whole set of traffic, and when we went to talk to users, either users on our v6 backbone or just or tunnel broker users, whether it be our tunnel broker or other people who were trying to get proactive in getting connected to v6, they were finding that there was still a lot of requirement for moving bits around on a 6 to 4 translation relay, and those relays weren't very efficient for them. So what we did was we went out and put beginning with seven 6 to 4 relays globally. And it took a while, it took a long while before we actually had any faith in doing this. And it made for a very interesting first day when we turned it on, turned it off, fixed a few things, and finally brought it into production. And we went around the globe very quickly getting this any-casted 6 to 4 environment up and running. And we've got about another 15 that we're going to deploy. And even with 7, we've managed to get ourselves a fairly good idea of what's going on traffic-wise. And we saw some stuff that which made sense. But what it boiled down to present it here was I turned around and I said, okay, let's look at what's going on between Europe and the United States with this traffic. How much of it's moving around? How much is bouncing? Just like we heard on the previous traceroute talk, where you can look at where traffic is going. The problem when you're looking at 6 to 4 or any other tunnel protocol is pretty damn hard to actually work out where everything is. So were getting a certain amount of 6-to-4 traffic on our backbone, but not a brilliant amount. But we had enough. And when we finished turning this all on, all the transatlantic traffic disappeared. So this is a summary of traffic between Europe and the United States. It seemed like the easiest place to measure this. We thought about doing it sort of East Coast, West Coast in the US, and then we sort of realized that where the 6-to-4 relays were today that were being anycasted really weren't quite in places that made any sense. But between Europe and the US, it made perfect sense. So we turned on the relays, and instantly we saw much of the traffic, well, we saw all of the traffic disappear from the transatlantic links, but we also realized that we were doing relaying both between V4 and V6 and between V6 and V4. And I'm not explaining what 6-to-4 is because you all have Google and Wikipedia, and you can go, and RFC editor, and you can go look it up. And if you don't know what it is, actually that's a good thing. But it's a transition mechanism that maybe will go away at some point. Bottom line was that improving the efficiency and getting traffic lower also meant that the user's experience, which really was the ultimate issue here, got to be better. If I look at the expanded graph, this was a different graph that showed it. I've got two problems here. If I've got a mouse. So this is the only graph that's going to show too much data. Right where my mouse is, oh, disappeared. No mouse. Anyway, right between week 1 and week 2 is when we realized we had S-flow data that we had to throw away. So ignore everything prior to that. But the bottom line was that we saw a reduction in the traffic going eastwards, going westwards. From Europe to the U.S. Right at that point, which made perfect sense for this type of traffic. We also ended up with this new customer traffic going over at some point as well. Now, the other one we looked at was Teredo. Again, we're dealing with these edge conditions, but guess what? It's the edge conditions that seem to be the hiccup for most new users when they sort of go, hey, I'm interested in this V6 thing, and you don't want to have too many hiccups. Now, Teredo is similar but a different protocol. But the bottom line was that we knew that there were relays that were operating, public relays that were operating, but there weren't very many of them. Again, the references on the RFC, or if you just want to read the easier to read Wikipedia entry, I do not recommend replacing IETF with Wikipedia. So we looked at that traffic. The gap is our data collection, not anything else. And we basically found that it was all on our backbone, completely eastward. We were taking traffic even from Asia in some cases and moving it all the way over to Amsterdam. Bit.nl was running their Teredo service. They've been running it for a while. Statistics are available on their website. I didn't bother to copy and paste them into here. I didn't have time to ask them for that, but it's available on the web. And they've been announcing the appropriate Teredo prefix for a while, as have a few other players. But these guys seem to get the majority of traffic at the present moment in time. And that means that, again, for a user that's interested in using Teredo, whether they are doing it willingly or unwillingly, whether they're doing it because it's just been automatically enabled on a Windows platform, or which can happen with the installation of certain software, or they've done it because that's the best practices way of getting two disparate V6 islands to talk to each other. You can, in fact, end up realizing that, yeah, we're moving an awful lot of traffic, even though 40 to 50 megs may not be a lot. This is the signaling traffic. The way that Teredo works is it's predominantly signaling with inside 2001:32. So that was sort of an interesting measurement. We haven't done anything about this. We're not that excited about thinking about running Teredo relays, installing 7 or 22 of those around the world. But it's again another one of these edge conditions. So where does this all lead me? So I've talked about traffic levels, and I've sort of tried to be about as balanced between proprietary and unproprietary. I'd love to throw up a graph of, which will never happen, of every peer to every peer, but that's just not going to happen. You know that. So the question is, outside of the quantitative, what's the qualitative aspect of this? At what point in time do we turn around and say, look, even if we have low bandwidth levels compared to the requirements that we have on an IPv4 backbone of installing N by 10 gigs, of putting 40 gig cards in, of wanting people who are doing 100 gig work to talk at this conference so that we actually understand where we're going to go next. So the qualitative thing is this enough reason to turn around and say, I need to be ready, I need to have IPv6 on the backbone? Well, you know this. I've been preaching this for a while. I've been preaching for a while. Even Dave's talk yesterday, really does show a balance. It's a little bit more complicated. There's a lot of other issues. There's an enormous, you can't take away from the fact that if you're running an access network, whether you're a cable company or a telco, you have an enormous amount of work, and you have some amazing complexity to deal with, and you have complicated decisions, whether they be carrier-grade NAT decisions or not. We have it easy. At the IP backbone level, we have it much easier. Moving the bits around is easier. So we went off and tried to find a non-traffic measure, and we started collecting, which we in no way have enough data to do time mapping on, but we started collecting information, and we started with just taking the easiest thing we could, dumping the .com domain every day, and then dumping through the whole of that, looking for every quad A record that could ever exist below every domain. So we would look for a quad A on example.com and on www.example.com. We'd look at the MX record and see if it had a quad A on MX records, see if it had a quad A, and just pummeling this. We, just in case you want to know how we did this, we actually built a DNS resolver cloud to do this, because as of a week or so ago, when I grabbed these data, there was 78 million domains. So that will blow up a domain. That will blow up a resolver pretty quickly. So this is what we found. So this is looking for all the people that had quad A records anywhere as best as we wanted to push. And we looked for IPv6.example.com as well, by the way, sorry, because that obviously exists. And we sort of found some interesting results. Now, some of these are either humorous, sad, or they show promise, or you just realize these numbers are just very low. But they're there. So we found, if you look at the key areas here, inside the 2000/3 area where you get unicast legitimate addresses, so we found 42,000 addresses. We found people out there that are actively doing work. Of course, we found lots of other stuff that just isn't what we wanted to see. V4 mapped addresses, V4 compatible addresses, which are two different things, and one's deprecated. We obviously found just a handful in the 6-4 space, which was sort of interesting, and we're unclear why that was there. The reason why some of them may say localhost, whatever. There may be good reasons for that. And as a note to Bill Manning, let 6-bone go, please. It needs to go. Just get rid of the last of the last here. The rest of them are all noise. We're now trying to run this. We can't quite run it every day. It's just too much data. And somebody's going to get annoyed at us. So we're working out whether we can do it about weekly at the present moment in time and actually start collecting some stats. We've been doing this, which has been on our IPv6 website. We've been collecting information much simpler than this, just looking at top-level domain, name servers and domains and the like. But the bottom line out of this is that there is this sort of gut feeling, and I'm an optimist, but there's this gut feeling that something's going on out there. It may not be that we see a majority of 78 million domains out there. Okay, so that brings us down to this. We're really down at the end now. Are we really going to turn around and say, I'm not going to listen until there's lots of traffic? Of course, there's not going to be lots of traffic until you listen, so that's an easy one. The second part is that are we going to dismiss the traffic? The comment about the fact that there's a fair amount of Usenet v6 traffic is not a bad thing, because it's being done between players that both know that they're v6 enabled, and they've realized that that type of traffic is perfectly acceptable. It's replacement traffic. It's not a new application, and it's this simple one-to-one replacement for existing v4 traffic. If you're not going to be ready for doing v6, then it's possible you're going to lose revenue if your business is based upon bandwidth. It may be that simple. It just may be that simple. And it really boils down to this last question. So does it really matter also which protocol it uses? Now, this has been another topic which came up. And I'll give you an example off of our backbone. I'll give you an example off a different talk. there have been some people that said, look, if you've got v6, you should use it. And I've scratched my head on this one a little bit, because if you have v6, yes, use it. But that if you have v4 as well, and you don't have a lack of v4 addresses at both ends, I don't think that's a penalty, and that's how we operate predominantly today. So if both ends are v6 and v4 enabled, sometimes you get a situation where someone will say, well, you should have used v6. Well, not really. You know, I may be an enthusiast about v6, but in reality, the final point is that you know, if you've got applications that are available in both of them, then it's not the end of the world if we keep going in the v4 world for traffic. It would be good to see. It would be good to see everybody, again, from an evangelical point, sort of pushing this, but it's not the end of the world. Anyway, that's what I wanted to talk about today. I wanted to just hit some traffic levels, turn around and say, you know, that this is not 1, 2, 10, 100 megabits around the world. There's a lot more than that. I've only got the numbers off of our backbone, so the theory is the numbers can only be higher if you look at everybody else's. That's it. That's what I want to talk about. And I obviously will take questions, comments, criticism, etc.
Good morning. Aaron Hughes-Carradine. I'm curious if you have split out tunnel traffic versus native connected traffic to figure out percentage of usage.
On our network, very low in the backbone side of things. So there are probably 2, maybe 3 major backbones that still need tunneled connections. And those are the ones that have pretty much the least amount of traffic anyway. On the end user, the people using tunnel broker type services, then I know from our stats they're very small compared to this. I mean, if it accounts for an average of about 20, well, maybe a bit more, maybe worst case about 40 megs worth of end user traffic as opposed to backbone. But tunnels on the backbone are really only really exist as peering tunnels where backbones are still running tunnel-based secondary backbones for v6 versus running native. For most people, when they're running native, you know, the tunnels are gone. So, yeah, small amount.
I just want to know why the v4 mapped quadrille records are so many in your network. I mean, if you use translator or something like that?
Why? Well, this is all out of these numbers here you're talking about. Yeah, these are all out of DNS. So somebody wants to type an FFFF address into a quad A. That's what they've done. It is amazingly high number, and it may just be complete misconception as to how to proceed.
So maybe the implementation mistake in that?
Human error, misconception, implementation. It's hard. I mean, the number's really high, and it's the only place that, well, yes, there are places where we see clusters of these, and then we see lots of random ones, and we haven't done any real cluster analysis on this yet. But I will tell you that, yes, there are a few domain shops where we see large amounts of domains registered and being held that have these v4 mapped addresses. So it could simply be one person making one mistake and therefore generating a large number of records. It's quite possible.
Yeah, Joel Yegley, I would look for, auto-configuring network appliances like info-blocks to be responsible for that. I'm not info-blocks specifically because I don't think it does that at this point, but there are a couple of those DNS appliances that have now supported v6, so I can imagine one producing that for every record that it created.
Yeah. The issue is that what we have not done is as I said, done this whole cluster analysis to where it's coming from. But they're out there, for good or bad. They're not the ones we really care about, to be honest.
Hey, Martin. So I think we at some point saw that that there are some products that automatically populate that to the gentleman's question or point down the front. So that's a big number to be like user error or an accident. And I mean, yeah. Now, one other point to your comment. I mean, frankly, I think it's the right thing to do if V6 is available. You know, to go with it, right? I mean, that's kind of the best way for us to keep things evolving. No.
The answer to that is yes. In other words, the more traffic there is, the more proof to the rest of the community that we have to do something. In your case, it's business case proof is what you want for your particular. You're an access network, so you want to see that. The subtle point is this actually came out of a conversation. I was always 100% pro. If you've got V4 and V6 connectivity, always use V6. And I sent an email from our V6 enabled mail servers. I sent an email to somebody else in the community here who promptly in the end of the email after addressing the subject said, by the way, you sent us an email on a V4 connection. You didn't connect via V6. And I said, well, okay, that's wrong. And I went back and looked at it and said, no, there's an MX record for V6, there's an MX record for V4. They're equal. There's no reason, I mean, it would be an artificial bias inside the code to actually have picked for, you know, as simple as a transaction as SMTP, to pick V6. And that sort of changed my mind a little bit here. As long as there's connectivity. And then, again, I'm cheating because I'm only talking at the backbone level, not at the access level, which you have a much harder task with. Anyway, so. All right, I'm done. Thank you.